How do you know that you can trust the formula for circumference of a circle? For example, how could you prove the circumference of this circle without a formula? In this lesson, you will prove the circumference formula of circles by dissecting a circle and making comparisons. Let's review. Diameter is the length of the segment whose endpoints are on the circle and contains the center of the circle. Remember that the diameter can be measured in any direction because the distance across a circle through the center is always the same. Circumference is the distance around the outside edge of a circle. The formula is c equals pi times the diameter. Because we're measuring the outside distance, circumference is the perimeter of a circle. A common misunderstanding students often make is confusing circumference with area. Remember that circumference is the distance around the outside edge of the circle, and area is the amount of square units of space a circle takes up. Now, to prove the circumference formula, let's dissect the circle. By unrolling the circle, we can see the circumference stretched out in a straight line. How does this compare to the diameter? Well, if we repeat the diameter, we can see how many diameters it takes to equal the circumference. Let's see, the diameter fits 1, 2, 3 times. Oh, but how far is this little segment? If we cut the diameter in half, then in half again, we have 1/4 or 25 1/100ths of the diameter. Now, if we cut that 1/4 in half, we have 1/8 or 0.125 of the diameter. Now, our little line segment is just a tiny bit longer than that, so let's go ahead and estimate it to be about 14 1/100ths of the diameter. Now, compare the circumference to the diameter. How many times do we need to multiply that diameter to equal the circumference? We multiplied the diameter by the 3 and 14 1/100ths times we used it. Now, this clearly equals our circumference, 18 and 84 100 centimeters. But does this look like any formulas you know? Well, sure, this looks like circumference equals pi times diameter. Apply the commutative property of multiplication, and we can reverse the order to show it like you remember. Now you have a good, although informal proof for the circumference of a circle. Remember, this proof holds true for all circles, regardless of their size, because we're comparing the circumference and diameter of the same circle. Also, you should keep in mind that we use 3.14 as an approximation for pi, but it's often important to use a more accurate value of pi with more digits, depending on your application. In this lesson, you proved the circumference formula of circles by dissecting a circle and making comparisons.